last speaker is Kevin Smith from the University of Minnesota. And then after that, we'll sort of reconvene the three speakers that are in the room, and we'll wheel VK back out and get the discussion going. Thanks, Kevin.
Thanks very much, Rick. And thanks for inviting me to be part of this discussion. I think the previous speakers have really done a great job of highlighting some important points to consider. And I would agree with Rick that this is a topic that seems to me to be quite daunting, but what's encouraging is that there are many, many paths to approaching this idea of how do we breed for a sustainable future. So the perspective that I'm going to try to bring to you this morning comes from my experience working at the University of Minnesota as part of this thing called the Forever Green Initiative. And the Forever Green Initiative is really a consortium of researchers and research groups that are working on an array of different crops and cropping systems, and it's unified by this, this goal of producing continuous cover cropping systems. So I don't need to remind most of you of some of the reasons why we might be interested in these continuous living cover systems, but certainly at Minnesota, one of the main drivers is water quality. So we know that the dominant annual row cropping systems, while being very productive, also can be very leaky in some cases with respect to nitrogen and nitrates. And that leads to some issues with water quality. So the goal in this Forever Green Initiative is to think about what are some other kinds of cropping systems that we can deploy on the landscape that will do a better job of keeping these nutrients in the system, and also providing some of the other ecosystem services that have been alluded to earlier by Jose and others in these systems. So again, this Forever Green Initiative, what we're trying to do is develop these continuous living cover systems. We want to try to improve soil and water quality, and we want to provide these ecological services. But linked to that, and importantly, I think, as part of this initiative, at least from my experience, is that there has been an acute awareness of the need to link all of these sort of research objectives of developing new technologies, new crops, new cropping systems, to their commercial viability. You can develop cover crop systems and you can tell farmers that it's great to grow cover crops, but if it's not profitable, if it's not sustainable from their perspective, if there's not some other viable benefit, then the adoption rate will likely be very, very low. So one of the things that I think has really been important in part of this consortium of workers is this emphasis on how we sort of in parallel work on the technology development, the breeding, the cropping systems, in parallel with what the commercialization of these new cropping systems or new crops might look like. So this is a kind of an overview slide of the Forever Green Initiative. It shows you there's a wide array of different crops that we're working on. A lot of these projects were actually in place and started before this initiative became sort of official. And really what the initiative has done is to bring together a lot of these different research groups and bring together multidisciplinary teams. So you can see that we have, obviously agronomists and breeders, but we also have people in food science, people who work in understanding the economics, and as well as education and outreach. So it's a broad interdisciplinary group. We have these teams that work on these different crops and cropping systems, and we actually meet on a weekly basis in sort of a lab meeting setting where we get to learn from each other about the various problems and challenges that we're working on, again, unified by this goal of producing and creating and deploying these continuous cover systems. So Kernza, I think most of you have heard about. It's kind of the poster child for the Forever Green Initiative. As a perennial grain. I'm not going to say a lot about it here, but this is work that was started at the Land Institute, and it's started 20-some years ago in terms of developing and breeding through recurrent selection, improved intermediate wheatgrass. That work has spread to different institutions, including the University of Minnesota, where Jim Anderson now is leading the breeding effort on Kernza at Minnesota. and released the first commercial variety of Kernza this past year called Clearwater. So there's certainly a lot of work to be done in terms of developing and improving this as a variety. The yields are not anywhere near competitive with annual wheat, but it is a beginning, and it's the first variety that's been released. It was mentioned even yesterday that there are already products on the market, and this illustrates this sort of parallel approach of how do we develop these new technologies and bring them to the landscape, but also make sure that there's an end user ready to use them. And it is a very difficult balance. You can have farmers saying, "Oh, great, I want to grow this," and we grow thousands of acres of Kernza, and then there's nobody that's going to buy the grain. On the other hand, you can have a big company like General Mills say, "Oh, Kernza, this sounds great. We want to market this product. We need, 100,000 acres of Kernza being grown next year when we're not ready there." So it's really a difficult balancing act to get those things to work in concert. I can talk a little bit more about another perennial grain or a perennial that's being developed. And I should say that the Forever Green Initiative has these sort of two different strategies for continuous cover. One is development of new perennial crops, and the other is to develop these double cropping systems, as was described earlier by Jose, where we have a winter and a summer annual combined together in some kind of a double cropping or intercropping system. So those are the two basic approaches. I'm working with a plant called Silphium integrifolium, or we call it Silflower. And this is, again, work that was started at the Land Institute by David Van Tassel, and then that work has spread outward to other institutions, where we now have a breeding program in place where we're trying to select for and improve this plant, which is a native prairie plant to the central part of the United States and the aster family, related to sunflower. We're trying to improve it and develop it as a perennial oilseed crop. But it is very, very clearly a domestication project. We're a long ways from something that might be a commercial cultivar, but it provides an opportunity to think about how does one approach breeding when you don't know what the end users are exactly, what you don't know where it's going to be grown, which traits are going to be important. So there's a lot of really interesting questions. And so as we brought this group together that are interested in working on Silphium, we wrote this paper a few years ago that was thinking about this idea of domestication and potentially over-domestication. And the idea is, what are some of the traits and characteristics of this plant that we really think are important as a new crop? In the case of Silphium, it was identified as very drought resistant. It's a perennial. As you can see, it produces lots of flowers, so it's important for pollinators. So there are all these properties that we think might be important in the broader sense as a new crop. And then what's the ideal idiotype going to look like, which we still have lots of discussions about on a regular basis as a moving target. But just to give you an example, one of these lines talks about flowering. So typically the wild plant has lots of flowers produced over a long period of time, 6 to 8 weeks really of flowering, which obviously makes it difficult as a agricultural plant to harvest, right? So what's the idiotype look like as a cultivar? Well, maybe it's going to have fewer plants or fewer stalks, or maybe it's going to flower more homogeneously or more synchronously to make it easier to harvest. Well, the extreme of that idiotype might look something like annual sunflower, where you have a single stem and one large flower, and they all flower exactly at the same time. So that might be desirable for some points of view, but if one of the ecosystem services that you want to provide is pollinator support, then you're going to lose that. So there's that trade-off. So at what point might we be over-domesticating as we think about how to shape and develop this species as a new crop? So I'll switch and just say a couple words about the other approach to these continuous cover systems, which is this idea of double cropping. I also have a barley program, and I've been working on winter barley and basically trying to improve winter hardiness in Minnesota, which is in itself a big challenge. But in this experiment that I'm showing you here, which is an experiment that is ongoing this summer, we're doing a direct comparison between a single crop soybean and a double crop soybean experiment. So the mature barley plots that you see there have already been harvested. We've replanted with a short season soybean. And the idea is, can we get two crops in our relatively short growing season to provide that continuous cover, but also provide a profitable system. And one of the reasons that I thought barley would be a good companion with this is that there's a huge interest in the craft brewing industry and the brewing industry in general in sourcing ingredients locally. And so trying to deploy and grow barley in environments that are close to where the consumers are is very attractive. Also, brewers are very interested in this idea of where their ingredients come from and telling that sustainability story. So you saw, I think yesterday you may have seen that there's a beer produced with Kernza, right? So part of that is marketing, right? It's talking about, that's called long root ale or long, something like that. So it's telling that story about where the food comes from and how it's produced as part of the way that we market it. And I think that's a key to trying to get some of these new crops and cropping systems to be deployed on the landscape. So we don't have data on winter barley per se, but there's other studies that have looked at these winter annuals and have clearly shown that when you include this winter annual compared to a conventional system where you have fallow, there's a strong potential to reduce the amount of nitrate leakage from those systems. And so in the experiment that I just showed you, in addition to measuring the productivity of those two systems, we also have been taking soil samples, deployed resin bags, so we'll be measuring nitrate in those systems as well. A similar approach that is being worked on by my colleague Aaron Lorenz, who's the soybean breeder at Minnesota, is to, rather than a double cropping, is looking at a relay cropping system. And so this diagram here shows you how that works. In this case, they're looking at pennycress, which is a winter annual oilseed crop that again is being domesticated as a new crop, and you can see here that the idea is to actually seed the soybeans into a standing crop of pennycress, so that you can create that continuous cover system. And this is kind of what that system looks like. On the left, you can see planting the soybeans into the standing crop of pennycress. On the right, you see the soybeans emerging and growing under the canopy of that standing crop. And then on the right, you can see what some of those plants look like. So clearly the plants, soybean plants that are growing normally in a monoculture system are going to behave differently than plants that are growing in this double cropping system. So as was mentioned earlier, it's really important to think about what are these different kinds of systems that we might be trying to create, and how does that affect those breeding targets. And so in the case of Aaron Lorenz, in addition to the traits that he's traditionally thought about for his soybean breeding program, the other things he has to consider are things like drought tolerance, because you're planting soybeans into a field that already has plants that are taking up water, and so water availability may be a real issue in the system. Or obviously there's a canopy, so shade tolerance, and possibly even allelopathy and other traits are important. So you have to really think about broadening the scope of traits that you're interested in. So I just want to end by sort of throwing out or recapping a couple of these ideas. Again, if we're trying to develop, if one of the solutions to sustainability is to develop these continuous cover systems, if we can agree that that's a reasonable strategy and approach, then there's a couple of things from a breeding perspective that you need to think about. We need to have breeding targets that are much broader than just bushels per acre. We need to really think about some of these other traits that are going to help optimize those systems. We need to actually breed for a system. So we're always breeding for a system, but some of these systems, like the double cropping system or relay system, might be much more complicated than the ones that we have traditionally been breeding for. So we need to think about what does that mean. And then lastly, I would say we need to think about some of those breeding trade-offs. As an example, in winter barley, one of the things that we're doing is breeding for earlier maturity so that we can plant those soybeans sooner and realize less of a yield penalty for late planted soybeans. But the trade-off is that earlier maturing barley is going to yield less too. And so I think that was shown earlier in the maize soybean system as well. How do you optimize that system so that you can, you're not going to get ideal yields out of any individual crop in that system, but how do you optimize the system as a whole through those breeding targets? So I will end there and we'll start with our discussion.